Hello. So today in this video, I'm going to teach you about what is regression spline or spline regression, right? So spline regression is a type of regression that is very different from other type of regressions such as linear regressions or logistic regression. It's not that popular, especially in times when we have machine learning algorithms. Spline regression is not as often used, but it is still used, right? It is used in many areas, in social science, in engineering sciences, but also in the industry, especially if you really want to do something very quickly. You really want to build a model very quickly. Spline regression is actually amazing, simply because it can take care of the non-linearity in the data, which logistic regression, linear regression may not be able to do that, right? And it's primarily used for regression, less about classification. So that's something to keep in mind. So let's learn a bit about the theory first. So it captures non-linearity. If you have data points like this, and if you fit a regression line, it will be a problem, right? If you fit a linear regression like this, it doesn't fit the data points, right? So you need to fit something like a curve, right? You need to fit something like a curve like this, right? And that's something that you cannot do using a linear regression, right? So non-linearity is its challenge in many applied problems across fields, actually, and that's when spline regression comes to our rescue, right? And the regression, there are different types of spline regressions. I will talk about that, but it is some kind of a local averaging. That means if you have too many data points like this, and in non-linear fashion, what you do is that you simply average out the local points in the vicinity, and then you connect them, okay, and that becomes a spline, right? And how many such local groups you want to have, that's something you will decide, right? That's something you can decide. If you have ever done machine learning, you probably know that what is a hyperparameter, right? So it's something in hyperparameter. That means it's something that you as a model developer, a researcher, can decide yourself. The more you do, the more chances of overfit. So do not do that. Do not have too many such groups, and something that you can choose, by the way. And it's non-parametric. It's not something that you can put in a more equation form. You don't have alpha, betas or something. And there are various types of splines. One is a linear spline, the easiest one, where you fit multiple regression like this. Then you have cubic spline, which is more polynomial form like this, right? And then there's a natural spline. It's very similar to cubic spline, except the fact that it ensures that it doesn't overfit, because spline regression is very prone to overfitting, especially when you fit a curve, a cubic spline to the data. The data will fit very nicely. The curve will fit the data very nicely. The problem is that it could lead to overfitting, right? So for the outliers, natural spline ensure that outliers are treated properly, and the curve doesn't overfit, right? It's used in many areas, by the way, especially in areas where you cannot build a parametric model. If you really want to build a quick model, right, parametric models are not the best choice, simply because it takes time to understand which factors, and and all you have to do all kinds of checks, such as linearity check, collinearity checks, and so on and so forth. Whereas non-parametric regressions like spline regression are not that sensitive to such assumptions or violation of assumptions. So that is something to keep in mind. So if you really want to build something very quickly, that's where it is quite useful. The second use case is when you have non-linear pattern in your data and you do not think that a linear regression would fit well, you go for a spline regression. So it's especially in the industry, right? It is used for quick prototyping. That means you quickly build something and you try to forecast something. And by the way, even though it's a model that is often considered as less scientific, less mathematically sound, it still does a very good job. Only if you know how not to overfit. Sometimes it does, but then there are ways to check overfitting, right? You can do a proper cross validation just to ensure. It's an alternative to ML models. ML models are also similar, right? They are really good at capturing the non-linearity in your data set, and that is something ML models are also good at. Spline is another option that you can try beside the other ML models that you know. This is some examples. Okay, here you see non-linear data, and you see a piecewise cubic. There are different types of cubic spline models. Here you see a linear spline, which is that, okay, this is a line that fits first part of the data, second line fit the second part. It's more like combining two linear regression, right? And how many such lines to fit is something that you can decide yourself also, right? But you can also fill curves, like the cubic splines will always be curve. Okay, let's see, let's take an example in Python and see how we can fit a spline. Alright, so here is this example. In Python, we'll be needing linear regression, but we'll be transforming the data, and that's the reason why we will need spline transformer, and both are part of sklearn, scikit-learn, so you can import that. We will get synthetic data. We do not have real data with us, so we are creating some sort of random data, but ensuring that it is non-linear in nature, right? So this is, by default. I'm going to show you also by plotting it later on, right? And there are very simple steps to perform a spline regression. First, you do the transformation, and here we are using B-spline. B-spline is type of a spline, but you can also use cubic spline. It's just about which transformation you want to make. Okay, and here you see that the degree for the cubic transformation is 3 and the knots are 5. You remember the local groups that I was talking about? That is nothing but the knots, right? How many knots you want. You do not have to have like too many knots, then it will be a problem, right? It will create overfitting. So have about 4 and 5, even 3 is also fine. And for cubic, degree is 3. But you can also choose, by the way, right? The number of knots is something that you can choose, and degree you can choose. You can make it 2 or 3, or you can just play around. It can also be used based on trial and error basis, right? The one that fits the best. And how you can choose that? You can look at the visualized curve, or you can just test it on a new data set just to see the performance, and then do that on trial and error basis, and then choose the knots and the degree for the one that gives the best result, right? So there's no hard and fast rule as such, but the only rule you have to follow is that you do not have to overfit, right? So make sure that the knots are not like 10 or 20 or something like that. Alright, then you just do a linear regression. You fit a linear regression line, and then we'll predict. Okay, we have plotted it. Here you go. You see the data points are very nonlinear, right? You simply cannot fit a linear regression line to this distribution of data points, right? The only thing that you can do is that you include dummy variables, but that's also not an option, especially in such scenario. Now, spline regression helps wonder. You see the curve, right? That fits the data points very, very well. But sometimes I feel that it's bit too well, right? It can also be an instance of overfitting, right? But it still does a good job, right? Compared to, let's say, linear regression. Even if you include the square terms and all, it won't be able to fit the data points very well. In machine learning, that's also a big challenge, right? You fit a tree-based model, it may not always give a good result, right? SBM type models can do well here, but spline regression is also one other option that you can try out, especially in industry framework, right? In industry, if you're fitting a set of data points and you want to do something quickly and just want to predict something quickly in the future, you can use spline regression. Note, however, that regression models are also used to find relationship between variables. That's something you cannot do in spline regression. or rather you that that option is not available. You can only use spline regression for prediction purpose, right? You want to predict things in the future, you can use, but not to understand relationship between dependent and independent variable. That is not good. That's something you cannot do, or rather spline regression is not the right modeling technique to do that. Alright, that's about spline regression in brief. I haven't gone through the mathematics behind it, but the mathematics, if you have ever done kernel density, fit a kernel, you have done that, it's very similar to that. Okay, and it's more like local regression. There is also another something called local regression. The mathematics is very similar to that. Again, it's just about